Let's take the derivative of y equals x squared times tangent of x divided by the quantity x cubed plus 1. Notice that in the numerator, we said x squared times tangent x. Two things multiplied that both have x's. That numerator is going to require a product rule. But notice that we also said divided by this quantity that has x in it. So because of that, we also need the quotient rule. So starting with the big picture, how we have a quotient, a numerator and a denominator. When we take the derivative, dy dx, using the quotient rule, we think low, d high. So low, the function that's on the denominator, low, d high, the derivative of that numerator. So because that numerator is a product, for the derivative of that guy, we're going to need the product rule. So quick reminder, f g prime plus f prime g, or simply one of the functions times the derivative of the other one, and then we switch it. X squared is our f, times g prime, the derivative of tangent x, secant squared x, plus f prime 2x times g tangent x. Finishing our quotient rule, we've done low d high, now minus high, that numerator, x squared tangent x, d low, the derivative of that denominator, 3x squared, over low, low, the denominator times itself, or squared. That is our derivative. We may or may not be able to clean it up a bit, but I'm going to stop there. Let's take the derivative of y equals 3e to the x times sine x times cosine x. Notice this time I said times twice. 3e to the x, a function of x, times sine x, another function of x, times cosine x, a third function of x. So yes, we have a product of three functions of x. This requires a product rule, which we're used to seeing as fg prime plus f prime g. However, we've got three functions here. So we can do a product rule with a product rule in it, or think about the idea behind this. We've got one function with the derivative of the other one, and then we switch it and add those together. Similarly, we can call these three different functions f, g, and h. And so our product rule for the three functions could look like this. F times g times h prime plus f times g prime times h plus f prime times g times h. Notice that we're multiplying all three functions where one of them is the derivative in each of those terms. Let's see what that looks like. dy dx equals the first two normal, 3e to the x times sine x, and then the derivative of that third one, derivative of cosine x, negative sine x, plus f, 3e to the x. This time the derivative of g, one that we haven't done, so the derivative of sine x is cosine x, and then times h normal, cosine x, plus, and now finally, a product with the derivative of f in it. The derivative of 3e to the x, 3e to the x. G and h as they are. Sine x, cosine x. While this is a derivative, this can easily be cleaned up. So let's go ahead and do that. Sine x times sine x is sine squared x, and we can move this negative to the front. So negative 3e to the x sine squared x. Cosine x times cosine x also can be written with the squared as cosine squared x. And this last one, sine x times cosine x, as it already says. This is an excellent answer as well, but usually you'll see if we can factor it easily, that's going to happen. So let's factor out 3e to the x and see what's left. Negative sine squared x plus cosine squared x plus sine x cosine x. Of course, we could stop there, but it's likely that if we were seeing a multiple choice question, we would be using some identities to simplify further. The combination of negative sine squared x plus cosine squared x, that sum, is the identity cosine 2x. Cosine 2x is cosine squared x minus sine squared x. Over here, we've got a version of the double angle identity. If we think about how sine of 2x equals 2 sine x times cosine x, well, this is the sine x times cosine x, but without the 2 in it. So if we divide both sides by 2, or multiply by a half, then that's what this equals, 1/2 times sine of 2x. So let's write our most simplified version. 3e to the x times cosine 2x plus 1/2 sine 2x. Make sure you know your identities. If f of x equals sine of x, find the sixth derivative of f of x. Well, you know we don't just straight jump into the sixth derivative. We have to go through the first 5. So let's get started. F prime of x, the derivative of sine x is cosine x. F double prime of x, cosine's derivative, negative sine x. F triple prime of x, negative of cosine x. The derivative of sine x is cosine x. And remember our notation when we get above 3 derivatives. Fourth derivative of f of x is the negative. That's our constant multiple. Be careful with cosine. Remember the co-functions have negative derivatives. So cosine x, the derivative is negative sine x. So this turns into positive sine x. The fifth derivative, notice we've cycled back around. Sine x, derivative is cosine x. That's where we were on the first derivative. So with these, you can start to see a pattern and perhaps save some time in the future when you see the cycle, when you notice the patterns. If f of x equals secant of x, find f double prime of pi over 4. First, before finding f double prime of pi over 4, we need f double prime of x. And of course, before finding second derivative, we need first derivative. So here's f of x. Let's write f prime of x. The derivative of secant x is secant x times tangent x. The second derivative is the derivative of that first derivative. Notice that we have a product here. So to do the second derivative, we need our product rule. Product rule says, take our first function, normal, multiply by the derivative of the second function. Derivative of tangent of x, secant squared x. Plus, now our first function, its derivative, secant's derivative is secant x tangent x, and then times the second function normal, tangent x. We can clean this up a bit to make our next step a little bit easier. Secant x times secant squared x makes secant cubed x. Here I have only one secant x, and then I'm multiplying tangent x times tangent x, which is tangent squared x. Now that we have f double prime of x, we can plug in the x value pi over 4. F double prime of pi over 4 is secant cubed of pi over 4. Another way to write that is secant of pi over 4, and then the parentheses around all of it, and then cubed, plus secant of pi over 4 times tangent of pi over 4 squared. Let's evaluate those. Of course, we know our unit circle, so secant of pi over 4 is square root of 2. square root of 2 cubed plus square root of 2 times tangent of pi over 4 is 1, so 1 squared. Square root of 2 cubed, of course, means square root of 2 times square root of 2 times square root of 2, so that makes 2 square root of 2. Square root of 2 times 1 squared is square root of 2, and then we can clean that up a bit because we have 2 square roots of 2 plus 1 square root of 2 makes 3 square roots of 2.